Welcome to this explainer, where we are going to bridge the massive gap between just having a theoretical understanding of electric fields and actually achieving top-tier, flawless exam execution. Listen, I want you to think of your Cambridge physics exam as a heavyweight boxing match. Seriously. To win this match, you don't just need raw power, you need high-level strategy. You need to float like a concept and sting like evidence. It is absolutely all about the jab, the cross, and the hook of your answer combinations. Today, we are looking at specific, battle-tested strategies for Cambridge syllabus codes starting from 0625, 0651, 0652, and 5054, all the way up to the highly advanced 9702 papers. And we are going to do this by looking closely at two hypothetical candidates that we see stepping into the ring every single year in the principal examiner reports. First, we have Alex. Now, Alex overloads the exam page with raw physics facts, but completely lacks any critical analysis. Alex comes out swinging wildly, throwing textbook definitions at the paper, just hoping and praying that something actually lands. It's a scattergun approach. Then, in the other corner, we have Sam. Sam's past papers are always covered in red pen marks from the teacher. Why? Because Sam rushes the process, gets caught up in the pressure of the clock, and completely misses the specific command word requirements of the question. Sam has the knowledge but zero ring awareness. By the end of this session, we are going to completely transform both of these flawed approaches. We're going to turn you into an absolute tactician. Okay, let's dive right into this. Think of this as your three-round bout. First, we'll cover theoretical foundations. Second, technical methodology. And finally, critical analysis and pitfalls. Let's step into the ring and get started.
Round 1. Theoretical foundations. Let's establish the absolute core principles you need before you even think about throwing a punch.
The fundamental definition you absolutely must know inside and out is that an electric field is the force per unit positive charge, represented by the legendary equation F equals QE. Now, what is really fascinating about this specific concept is how beautifully simple it seems on the surface, yet it is consistently one of the most widely misunderstood areas in the entire physics syllabus. When our candidate Alex sees a question about this, Alex just immediately brain dumps the equation onto the page and expects full marks. But let's look at this through the eyes of the examiner. To the examiner, F is the specific electrical force experienced, Q is the specific charge placed within the field, and E is the electric field strength. Now listen closely, because this is where the knockout happens. The critical phrasing here, the part you must highlight, underline, and engrave in your mind, is the phrase per unit positive charge. If you write your definition and you forget the word positive, you drop the mark instantly. Your guard is down and the examiner penalizes you. The entire theoretical architecture of this topic rests heavily on precise definitions and very specific causal relationships. You literally cannot just memorize the letters of the formula. You have to know exactly what physical reality those letters represent in the context of a Cambridge exam. It is about precision, not just recall.
The absolute top-performing students, the ones securing the highest grade boundaries, they don't just blindly memorize this equation. Instead, they build a deep, unshakable conceptual understanding that seamlessly integrates with other areas of the syllabus to tackle completely unfamiliar contexts. And this beautifully illustrates where the Peel framework comes into play. If you don't know PEEL, write this down right now. PEEL stands for Point, Evidence, Explanation, Link. This is your ultimate jab, cross, hook answer combination for structured questions. When you are addressing an electric field question, your point is the jab. It states the core physics principles straight away, like identifying the specific direction of the field. Your evidence is the cross. It refers directly to the data, the numbers, or the diagram provided in the specific exam question. Your explanation is the hook. It details exactly how the force acts on the charge using F equals QE, showcasing logical, highly structured reasoning. And finally, your link brings your combination together. It connects everything back perfectly to what the command word actually asks you to do. This framework literally forces you to exhibit connected conceptual understanding, rather than just throwing random facts at the wall, like our friend Alex does. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Round 2. Technical methodology. We've got our theoretical footwork down, so let's move on to the systematic processing required to win on points. You need to realize that examiners enforce extremely strict conventions for how you present your information. This means proper headings, highly precise terminology, appropriate formats, and crystal clear annotations are absolutely mandatory. They are not optional if you want top marks. Let's talk about our other candidate, Sam. We constantly see Sam's rushed, messy calculations where variables are scattered everywhere across the blank space, numbers are floating around without any units, and the logic is totally hidden. We have to transform that approach by strictly adding proper headings and using the exact approved terminology straight from the 9702 syllabus. Why does this matter so much? Because data interpretation skills are absolutely critical in this heavyweight bout. You constantly have to extract raw data from complex texts and tables and interpret those relationships clearly for the person marking your paper. By organizing your format and explicitly annotating every single step of your logic, you are literally speaking the examiner's language. You are making it absolutely impossible for them to miss your correct physics. You are forcing them to give you the marks.
To systematically process these complex exam problems, you must always use this standardized 5-step sequence. It starts with identifying key elements and ends with appropriate presentation. Let's break this down into a highly tactical, foolproof process. I call this the physics success blueprint. Step 1. Identify key elements. This means actively decoding the command word. Stop and ask yourself, is the examiner asking me to describe, to explain, or to determine? Those words demand entirely different punches. Step 2. Apply principles. This is where your core theory, like F equals QE, enters the ring. Step 3. Execute with clear working. Listen to me on this one. You must explicitly show your substitution of the numbers into the equation before you ever touch your calculator. Step 4. Verify results. Take a breath and ask, does your final answer physically make sense? Is the magnitude completely outrageous for an electron? Step 5. Present properly. This means using the correct significant figures and the standard SI units. This blueprint is exactly what turns an average, anxious student into a top-tier, confident candidate. If you skip step 3 and you just quickly scribble down a final answer, you are leaving your guard entirely down and you will lose points unnecessarily.
This perfectly illustrates the absolute core of the method mark strategy, proving that advanced physics is just as much about your rigorous analytical procedure as it is about your final calculation. So the crucial takeaway here is that examiners actively want to reward you for your process. The system is designed to give you points if you show your work. Imagine this. If you correctly identify the electric field strength E and the specific charge Q from the data, but you make a silly high-pressure calculator error when finding the force F, a clearly laid-out method guarantees you still pick up the vast majority of the method marks. You are rewarded for the rigor and clarity of your analytical approach. The Cambridge syllabus explicitly prioritizes this kind of analytical depth over superficial breadth. Think of method marks as winning the round on points, even if you miss the final knockout calculation.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Round 3, Critical Analysis and Pitfalls. Let's look at deep evaluation techniques and the most common mistakes that cost candidates their target grades.
True. High-level problem-solving requires a strict deconstruct, solve, and evaluate approach, where you break down your logical steps and explicitly check your answers for real-world reasonableness. Let's do a quick, interactive workshop right now to test your ring readiness. I want you to imagine an invisible 60-second visual countdown timer ticking down on your screen right now. Tick, tock. I want you to picture a highly complex physics data source in front of you. Let's say it's a graph plotting electric force on the y-axis against charge on the x-axis. Challenge 1. Data scan. You have 60 seconds. What is the core trend of this graph? Your mental deconstruction process should instantly tell you that a perfectly straight line passing straight through the origin means that force is directly proportional to charge. And taking it a step further, the gradient or slope of that specific line represents the electric field strength E. That right there is how you solve systematically. You don't just passively look at the line, you aggressively extract the mathematical relationship, and you evaluate its physical meaning in the context of F equals QE.
When you are analyzing systems, you must compare by identifying both the similarities and the differences, and you must always use comparative connectives while supporting your claims with hard evidence. Let's move straight into our next interactive workshop challenge. Challenge 2. Find the flaw. I'm going to read you a flawed sample physics paragraph, and I want you to spot where the marks are bleeding out. Here it is. A uniform electric field has parallel field lines. A radial field has lines pointing outward. Okay, time's up. Did you spot the exact sentence losing marks? The massive flaw here is the total lack of comparative connectives. To get the full top-tier analysis marks from a strict examiner, you must use bridging words like whereas, however, or in contrast. A perfect A-star answer actually reads like this. A uniform electric field has parallel equally spaced field lines, whereas a radial field has lines that diverge outward, indicating a decreasing field strength. Do you see the difference in quality? Now for challenge 3, speed writing. In your head right now, take 30 seconds to write one perfectly structured Peel paragraph comparing the force on an electron versus a proton placed in the exact same uniform electric field. Remember your framework: point, evidence, explanation, link. Keep those comparative connectives front and center. You'd point out the forces are equal in magnitude, provide the evidence that they have the same magnitude of charge, explain it using F equals QE, and then link it by using a connective like however to state the forces act in perfectly opposite directions because of their opposite signs. That is a knockout answer.
We reviewed years of the principal examiner reports, and there are exactly 3 major repeated mistakes that students consistently make under exam pressure. Listen, this is direct hard data pulled right from the source. The examiners are literally handing us the scouting tape on how students fail. They have told us exactly where candidates routinely drop their guard and lose easy points on electric field questions. I'm going to share these with you so we can make absolutely sure you never make these critical errors when you step into the exam hall. These top 3 devastating errors are using the wrong approach for the context, totally forgetting your formatting checks, and providing answers that are generic rather than specific to the given scenario. Let's systematically break these down. Mistake number 1. The wrong approach for the context. We see this all the time. This happens when a stressed student uses the equations designed for uniform electric fields in a question clearly describing a radial field context. It immediately shows the examiner a fundamental lack of conceptual understanding. Mistake number 2, forgetting format checks. This is the classic trap our friend Sam falls into. It is rushing through the final hurdle and forgetting to write down the standard SI units or providing a calculated answer to 4 significant figures when the raw data provided in the question only justified 2 significant figures. You will lose the mark. And finally, mistake number 3, non-specific generic answers. This is our friend Alex's signature move. It is copying out a perfectly memorized textbook definition of an electric field without actually applying it to the specific parallel plates or the specific point charges described in the unique exam scenario. As this critical examiner alert perfectly highlights, generic answers will cost you dearly. Every single point you make must actively link back to the specific context. This right here is the L in our PL framework, the link. This is where you seal the deal. If the exam question specifically asks you about a microscopic oil drop suspended in midair between 2 charged plates, your written answer absolutely cannot just be a generic, floating explanation of F equals QE. You must get specific. You must explicitly state that the upward electrical force acting on that specific oil drop is perfectly equal to the downward gravitational force acting on it. You must link the abstract theory directly to the concrete physical scenario in front of you. Now listen up. Students who implement these specific physics strategies see an average improvement of 2 full grade boundaries, but that only happens if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. So, to truly master electric fields and dominate the syllabus, you have to ask yourself a hard question. Are you just stating the background theory, or are you actively solving the specific context in front of you? The next time you sit down and look at a complex physics problem, don't just act like Alex, wildly throwing random facts and hoping for the best. And whatever you do, don't panic and rush through the command words like Sam. You need to step into that exam hall like a true strategist, float like a concept, sting like evidence. Assess the data with a cool head, apply F equals QE with absolute surgical precision, follow your PEL framework, and systematically conquer the paper. I want you to drop a comment below with your exact target grade for physics and the biggest single challenge you are currently facing. Our team responds to every single comment. Like and share this video with a study partner who needs to hear this. Ace the Exams, your Cambridge success starts here. Until next time, keep analyzing, keep evaluating, and keep mastering the blueprint.